of the core of everything. So what does it entail to make a demo like this? What did I go through as a learning experience? Let's go ahead and close all this stuff. I made everything basically in Blender first. I've never used Blender before, but this is like the RN module. So if we go back here, then you can see that that's going to be what is populated right here on the development board. Some things in this world, like that's a separate model and things like that, are going to be like this. And this is actually one object, and then this is another object. Oh, let's go ahead and open this. It'll be easier. So this is a no back object, and then here we can see the back. And so what this is actually a child that I've attached to a parent so that it moves inside of the relative space along with it. So this was done by me just dragging the object over and doing hard coding pairing, but you can sever this child from the parent and separate these components and things like that, so you can actually assemble boards, which I've done in a different demonstration. But you can use certain pivot points inside the object to do the parenting and the childing, to give that real-time tracking kind of cool stuff. So this is the whole project. All these objects were basically made, close that, inside of Blender. So depending upon the scope that I was looking to create, you have more complex objects that may have been created. So I don't have these available for everybody. But it was, a fun learning experience that you can go through to learn a lot about these type of models. And those get brought into the Unity world. And then over here we have our game objects. So this is actually the canvas. So you may have seen text on the screen. This is just like an overlay text that exists on type of the display screen as users are playing with things. Here we have our lights that are the room lights, the cool lights, and then the room lights. So this was actually what is being used for the temperature sensor. So temperature values with the embedded data are actually enabling and disabling these lights based upon the data that comes in. These are the moving objects. So these are attached to the embedded code, the embedded object code basically. We'll get there in a second, code logic, that takes it in. So like this wink you can see is this wink right here. And so I'm saying this physical object inside the VR world I want to attach to hard coding to this messy main to do this behavior, because we're doing a relatively simple demo. But we could have dynamically spawned this object and then attached it to the script through an interface or something along those lines. So wedge objects are all the different wedges that we are going to see. So this is the large wedge. So these were just a lot of different demonstration boards that I wanted to kind of show off inside that space. Action objects is going to be this ball right here, and then we can have these LEDs. So these are actually being tracked. So over here you'll see a tracked light, and then you'll see the tracking light. So this tracked light is actually on the board right here. So these are our master lights in the scene. And then all the other lights that were attached to those BLE boards are actually doing an observer on these lights. So these are observing those lights. And if those lights change states, then these will change state. So that's kind of how that behaves. RDD is a serial controller. So this is what you get when you get the plugin. You will get RDD. It attaches to a raw COM port at our baud rate. You can make these dynamic. That would be up to you if you're really looking for that. I only have one COM port, but obviously we want to enumerate multiple COM ports. We would want to make this an inheritance or assigning. So then you have your serial controller. So this controller is the RDD controller. And then this read-write user polling, if we go into it, this is actually the code that is supplied with the library. So you can look at Daniel if you want to go read more about this guy. And then they bring in the elements that are necessary. So here's the actual controller. This is my public object. So this is where I brought in another script that I wanted to pass my data down to, which I'll get to. Starts the controller on on initialization of the application. It waits until it's connected or in a disconnected state, and these will handle those. And then otherwise, it's going to go ahead and read any serial messages as they arrive in the update. So on every scene update, instance update inside of Unity, it's going to go ahead and read, see if there's a message there. If there is a message, then it's going to pass that message. So this is my script and then my extension to processing it. So you can get into that. What we're doing here is we're just making sure that it's formatted as we expect it. If it's not formatted as we expect it, then we're going to go ahead and echo it out to the serial terminal as a string. So this is where, yeah, we just echo it right back out. Not a big deal. If it's under 32 bytes. Characters, sorry. So JSON format, so it'll go inside of here, and what this is doing is I just make sure that it's formatted as I expect. I remove those formatters. There's probably a JSON library that you can use. I didn't have time for my demo to fully find those things, so I implemented my own design, which was just really quick and dirty. We split it up into a map and create a key value pair, and then we basically look for what the key is going to be, whether it's a temperature, push button, LEDs, accelerometer, whatever it may be, and things along that nature. And then we parse that data. So like a push button, we just go ahead and get into it. We're going to say, well, I've passed my value into it. We're going to enable those, and then we enable the lights true or false, basically. So this is the VR light that's tracking inside of this ball. So if we went to action items, VR light. So this is the VR light that is being manipulated directly through here because we had a dirty main in the embedded object code. So it'd be pretty easy to break this apart, make it cleaner, make it more encapsulated for your specific feature. I was just trying to show a lot of different behaviors with data in a quick and dirty, easy way. Yeah, so that was kind of all that goes on there. You can read this more if you want, but the majority of it is just putting objects inside of specific locations inside of my Unity scene. So it gives us a dead reckoning origin location. These are the dirty main elements, so it lets you get access to everything. Everything else is private if it can be. We initialize it inside of here to everything in its default scene location so that we know what we're working with. Everything as appropriately. We don't actually use this, so it can probably get dropped. And then the update gets called. And so what this is doing is this is actually updating the on-screen text that you were seeing. This lets us do, if the user presses P on the keyboard, then we can do a test data. So you can go ahead and test that, do whatever behavior you want. This just reloaded the scene. And then these are the push button things and everything like that. So this is pretty well encapsulated or specific for what it's going to be doing. You can look through that if you would like. Otherwise, the only other important thing would be maybe looking at this code. So most of our communication is happening over the UARTs, so that's our peripheral of communication. Two files that we probably care most about is going to be main and VR services. VR services is the custom code that I've written, and then main is our main while loop. So let me just go through this real quick. A lot of our stuff are local variables that exist inside of our dirty main. We have our system initialization, so this configures our peripherals and our hardware abstraction layer and our physical layers and things like that. This is going to be the Bluetooth module's asynchronous handler. So what this is actually doing is it's reading messages that the Bluetooth device communicates back to the embedded device, and then it is taking care of the data streaming mode or the command response actions. Don't need to worry too much about that, but that is in the driver. Enabling the interrupts allows the UARTs to work and to communicate properly. And RX initialization is going to initialize the RN module for operation. So this lets Bluetooth work. So this is going to be this is our while one loop. So this is our cooperative loop. You can think about this as being the update call inside of Unity. It's just isolated for this specific embedded device. What this is doing is it's just doing a simple tick counter. So the peripheral is running, and once it overflows, then we are going to reset the peripheral so that it can rerun again, and then we increment our scheduler in a polling method. We check to see if we're connected from the Bluetooth driver. If we are in a connected state, then we are going to go ahead and see if we are ready to do a Bluetooth communication. So we don't want to talk all the time. We want to schedule ourselves to only talk at certain interval rates so that we don't flood our resources. So that's what that's doing. This breaks it up in the communication. So this is where the temperature data goes, accelerometer data, push button LED states and things like that to the light blue application. Then if we are still in a connected state, but we are not doing a Bluetooth operation, then we are going to go ahead and get into this other mode of operation, which is says that, well, are we listening from the device? Do we need to basically parse any of the response data? So we have data coming in. This is usually like parsing the serial data, something related to that. So that's what this one specifically does. So it gets inside here. It says, well, we have data. Let's go ahead and read that data. So what this does is the light blue, if I like toggle the LEDs from the push button in the light blue application, this does those generic actions. If it is serial data, then you'll get inside of here. So we're going to go ahead and we're going to read the specific serial information. If it has serial data, we're going to process that according to whatever light blue application needs. And then I hijack that data and I push it out onto the serial data. So that's actually what you were seeing. That's how we print it out to the terminal. And then that is, what we toggle the LEDs on and off for. So what we do is if you actually write data off, data on, things like that, it'll toggle the LEDs on the physical board appropriately. Otherwise, we just keep moving. So if we're not in a connected state, then this is going to supply pass-through between serial connected board connection. So on this board, it is actually right here on, oh my goodness, what have I done? Right here on the back. So if this is connected, this will actually give you a CDC bridge through the USB device to the embedded device to talk to UART to the module. So the module itself actually has raw commands that it's allowed to do. And if this isn't connected like to the phone application, then you can do raw commands directly to that module to put it into whatever mode of operation you're looking for. That is what's occurring right here. So if we are not connected, this becomes our virtual reality specific code. So the end of the normal application ends here, and then this is my custom implementation. So if we are not connected, we can talk faster because I don't need to give priority to the phone application. So that lets us do our VR communication at a faster rate. Otherwise, you have this bad boy, which is basically going to say, if we are in a connected state right now, I want to slow down the communication that I'm doing with the virtual reality world because I want to give priority to the phone application. That is a user choice in this case. So otherwise, we're going to go say, well, if we have to do a VR task, so if this guy's true, then let's go ahead and do our print task. So this could have been probably just been VR task here, but I think that this was done so that you could break it up if you wanted to further. Otherwise, it clears everything. So all data, what this will actually do is this just formats the LED data, temperature value, accelerometer, and everything into the JSON format that would be expected, and then it sends it over. So if you want to look at that kind of format stuff, then that all exists inside of this VR services file. So you can read this deeper if you want to look into the formatting of the data. And this would give you a good example of how if you wanted to create your own thing, then you can. So this is just, these are all the different support features, and then this is the packet interface, basically. So otherwise, if the virtual world is communicating down to the embedded device, then we'll do some type of behavior. So the 0, 1, 3, 4, this is where the red and green balls that go into those little basket bins, right over here, that's where this logic is occurring. So yeah, that's pretty much the entire project. So again, the source code for the embedded project is here. You can go to the CES example. I'll link this under the video. And then same thing is that if you want to play around with this Unity project, you're more than welcome to. It's going to be right here. You can clone it, download it, fork it, whatever you want to do. Yeah, so I hope this was informative. I hope maybe somebody out there was able to leverage this to accelerate their own development process on an application or a project that they're working on. Or if worse comes to worse, I hope that it was an enjoyable watch. So thanks for watching, and goodbye.